Alright, so this is section 9-2, part 3, or C. I broke it up into 3 sections so it would be easier for you to go through and find what you needed on the videos. Alright, so according to this problem, some rating company, Nielsen's, checked out the amount of time. So this is the amount of time spent of MySpace users per month in July of 2014. And it was 171 minutes. So, and they want a 95% confidence level for the amount of time, the average amount of time the population spends on MySpace, and they say it's between here and here. So I can build a picture from this. We have this thing going on. We know that the X bar was equal to 171, and that was our point estimate. We know that this is 0.025 out here in the tails because of the confidence level being 95%. We know the upper bound was 190.6 and the lower bound was 151.4. So they're asking, what does this picture mean? Okay. With a 95% confidence level, the average amount of time spent by the population on MySpace is between 151.4 and 190.6 minutes. God, what is that? So what is 154? 154.4 divided by 60. It's 2 hours and 2.57, so subtract 2 and then times by 60 minutes in an hour. So that equates to 2 hours and 34 minutes a day on MySpace. What a waste of time. Okay, so that's how you interpret that question. It's a waste of time to MySpace. I cracked up because the reason this book was purchased was because its problems are more current. How long has it been since anybody ever heard of MySpace? Alrighty, so the next one here is the following data represents a repair cost for low impact collisions. A simple example of mini and micro vehicles, so such as the Chevy Avino. I don't even know what that is, but I know what a Mini Cooper is, and I know they're expensive. So they want us to draw a normal probability plot to determine if the reasonable conclusion. So we talked about this. The book really doesn't cover it very well, but I'm going to show you where it is. First of all, you have to put this data into your calculator. So I'm going to hit edit, and I've already put the data in list 1 to save myself time on this video. So these numbers have been entered into list 1 for me. I'm going to get out of here. I'm going to draw what's called a normal probability plot. And so what a normal probability plot is you have your scores down here, your x values, and then you're going to go from 663 all the way up to 3345. So these are all your x numbers. And then over here you're going to find the mean and standard deviation, and this is 0, and these are z-scores. And so what you're going to get is a plot of the z-score compared to the data. All right, so the way you do that is you go second, y equals, and you turn your plot on. So you go to plot 1, turn it on, and you got to go, I make sure it's on, then go down, and it's this one right here. It's the very last one. So I'm going to go sideways over to that last one and press enter. And it's going to ask me for my data list, and my data list is in list 1. And they want to know what is my data list axis. I'm going to use the x-axis because this is my data down here. I'm going to use that as the x-axis. And so then I'm going to hit second quit, and I'm going to go zoom 9. And there's my normal probability plot. So it starts off down here, there's a dot here, and it kind of goes up a little bit, and then they kind of go sideways a little bit, and it goes up a little bit. So if you look at this, it's pretty close to a straight line. So that's an indication that this distribution up here is pretty close to normal. All right, so that's how you do that one. Now, if you don't know how to do that one, you certainly know how to do this one. So we want to draw a box plot. All right, so we know how that works, and it kind of is going to be a straight line like this with a box on it. And my lower number is 663, and my upper number is 3345. And then I can go here and hit edit, and I already sorted this list and I know where the middle is. So if there's 10 points, the middle is between 5 and 6. So where's 5? There's 5 and 6. So the middle of 5 and 6, so that would be, this is the middle of 5 and 6, so this is 773. And then the middle up here would be, so back 2 from there. So that looks like 2637. So this is 2637. And then I got to go up and find these two guys here. So I have to, looks like I have to add these together. That's 5, wait a minute. That's 5 and that's 6. 5 and 6. So I have to take, this is the middle. So the middle one is going to be found with x tilde is going to be equal to 1758 plus, and I'm going to go down one, no, up one, plus 1370 divided by 2. So then I'm going to go, let's go second quit and do 1758 plus 1370. Get that number and divide by 2, and that's 1564. So 1564 is the middle. So there's my box plot, and it looks kind of normal. I can also do that with the calculator here. I can turn that guy on, go down, and do the box plot. And I want the box plot, this one here, because it shows outliers. So I hit enter, and my x list 1 and the frequency of data is 1 each. So I go second quit, and then zoom 9, and there's my box plot. I can trace on that. There's my middle, 1564. There's my upper bound, 2637, so that's correct. Go down to my lower bound, 773, my lowest number, 663, and my upper number, 3345. And I already know there's no outliers, but I could check for outliers if I wanted to, and I'd have to find the interquartile range. So the interquartile range would be equal to 2637, take away 733. So I want to get out of here. So is it 2637, take away 733. So that's equal to 1904. Now I know my upper, I'm not worried about the lower one, it's the upper one that's a little bit disconcerting. So the upper fence is equal to Q3 plus 1.5 IQR. So in this case it's going to be 2637 plus 1.5 times 1904. So I'm going to take 1904 and times it by 1.5, and then I'm going to add 2637. Oops, back up, 2637, and that gives me 5493. and that's way past the upper limit, so I'm good. So there's no outliers, and it's kind of normally distributed, although if I go back it's a little bit skewed. All right, so let's keep going and carry on. All right, so we want to construct a 95% confidence interval for the population mean cost per repair. So from that, we already have the data in stats, so I'm going to need some stuff. I'm going to need to know X bar. So I go stat, sideways to calc, and I hit list 1, second list 1, and enter. Oops, did I hit a plus sign there by accident? I did, huh? Delete. Okay, so go there. All right, so the average is 157.6 or 1756.5, and SX is 1007.45, 1007.45 and some change. Right? I'll see N is equal to 10, so my degrees of freedom is equal to 9. My confidence level is equal to 0.95, and alpha is 0.05. So my picture is going to look like this. I'm going to put it up here so I got some room down below. So my picture looks like this. I got 0.025 in each tail. And remember that 0 is in the middle. And I'm going to go find those z-scores, or t-scores right now. So I have 0.025 and 9 degrees of freedom. So I'll go get the table and move this over. Scroll up a little bit. So I said 0.025, that's right here. 9 degrees of freedom gives me 2262. So is that right? 2262. All right, let's go back over here. So now I know that T alpha over 2 is 2262. So this one over here is 2.262, and this is minus 2.262. So now I can find my error. So the error is equal to 2.262 times 1007.45. Clean that up a little bit. 1007.45 divided by 10, or the square root of 10. All right. So far so good. Yeah. All right. So now I gotta get that in a calculator here. So clear. 2.262. So 2.262 times 1007.45. I'll just type it in here. Divided by the second square root of 10. So I get this number. So my error is 720.63. And I'm going to store that as alpha A. Now I know the mean is this guy here, so I know that the confidence level is going to be, I know this number right here is 1756.5, and I want to figure out these two numbers here, so I'm going to add my error and subtract my error from my mean. So X bar minus the error is less than mu is less than X bar plus the error. All right, so I'm going to do that. I'm going to get 175.6.5 plus alpha A. No, I'm going to minus alpha A, and that's going to give me 1035.86 is less than mu, and then I'm going to go second enter, just bring this back up and change that to a plus so I don't have to type it over again, and it's less than 2477.14. So this is the range of values, or the average cost of repair for a mini or micro vehicle. So with a 95% confidence level, a 95% confidence level the average repair cost for or of a microcar. I've never heard it called that before. Is between $1,035 and $2,477. Okay, so that's how you do it. And so this is how you do it with lists. So now I'm going to actually do a T interval to check my work. Okay, so what does that T interval look like? So I hit stat, tests, and I go down to T interval. And you notice that X bar is already there, and so is S, and so is N. Because I remember I entered this data into list 1, and so the calculator's looking at list 1 and it's pulling these numbers up. But this confidence level is not correct, so I want to go down here and change that to 95. And so then I'm going to calculate, and hopefully I get the same numbers. So what does the calculator get? 1035. So 1035, comma 2477. So I got the same answer as the calculator. That's a good thing. Alrighty, that takes care of that problem. So we showed you how to use this calculator to find that, to check your work, but never use the calculator to just get an answer. Always show that you understand the concepts of the course and show the work. Right, suppose you obtain a simple random sample of size n equals 10 of a Mini Cooper that has low impact collision and determine the cost of repair. Do you think a 95% confidence interval would be wider or narrower? Well, let's see here. If I was just dealing with one car, I don't know if I would assume it'd be wider because Minis cost more than other cars, but I really don't know that for sure because I don't know all the micro cars that are out there in the world, but I know it's more expensive than a Chevy. So all I can say is because you would be looking at only Mini cars, or Minis, that's what their brand name is, Mini Coopers, C-O-O-P-E-Rs, Mini Coopers. So since you'd only be looking at Mini Coopers, the distribution of costs would likely be different. Than with a variety of cars. So this distribution up here is more than one car. So this is more than one type. But if you had just Minis, I would venture a guess. I wouldn't be able to say it for sure, but I'd guess that the costs, the stair, it would be narrower. So the range would possibly be narrower. Okay, so I guess that takes care of that one. Okay, and then what's next here? Oh, that's it. Oh my God. Done. F10. All right, we're out of here.